Hello and welcome back. Today we continue our discussion by talking about congruent angles, proportional sides, and similar triangles. So let's get started. In the previous video, we were talking about how if you can prove that two angles of one triangle are congruent with two angles of a second triangle, then it will be implied that the third angles are also congruent, and then you had similar triangles. You could then use a proportion to find the missing side of one of those triangles after proving that they're similar. So we're going to continue talking about that, except today we're dealing with triangles that are not right triangles. And you might find in the problem that you're doing that the triangles do not look alike. In the previous example, they clearly looked very similar. One was just smaller than the other one. But in this example, they don't look alike at all. And you're going to have to do the math, basically, to prove that they are similar based upon their measurements. And that's how you approach this type of thing. So let's read the question. It says, an architectural firm is making a model of a house. At this time, they are developing a model for the roof. In the model, the line AC equals 11 inches, AB equals 12 inches, BC equals 5.3 inches, and the measure of angle A is 26 degrees, the measure of angle B is 24 degrees. If you look at the smaller triangle, this represents the model of the roof, and I already have it labeled. And let's keep reading. It says, in the actual roof, the line DF equals 99 inches, DE equals 108 inches, FE equals 47.7 inches. And so you're supposed to find the measure of angle F in the actual roof. So we have to determine whether the triangles are similar to see if we can use any of the methods. And one way to determine if two triangles are similar is if three angles in one triangle are congruent to three angles in the second triangle. And remember, I said before, you don't actually need to prove that all three angles are congruent. You just need to prove that two angles in one triangle are congruent to two angles in another one, and then the third angles will be it'll be implied that they're also congruent. But the problem here is that we don't have any of the angles labeled in the model of the actual roof. So we're going to have to use another method. You remember when we used the proportion in the previous video? After we proved the triangles were similar, we used the proportion to find the missing side. Well, since we have all of the sides labeled, we can kind of work backwards and use proportion to prove that these triangles are similar. So let's try that. If we're going to use a proportion, we're going to have to line up each side with the corresponding side on the other triangle. So first of all, let's do that. If we're going to use a proportion, then the line AC would be, we put AC with DF. So AC over DF, we do that proportion. And then we would do AB in the model, AB in the smaller triangle with DE. And then we would line up BC or CB, either way, we can put BC, with EF. Okay, so this is just showing you how the sides of one triangle correspond with the sides of the other one. So now that we have that determined, we're going to put in the numbers for these sides and make our proportion. So AC was 11 and DF was 99. And remember, these would all have to be equal. You know, these will all have to be equal to prove that our triangles are similar. So we're going to put an equal sign after it, after the ratio. So moving along, AB was 12 inches and DE was 108. and this would have to be equal to the proportion of BC, which was 5.3, and EF, 47.7. Okay, now what's going to happen is when you do the math on all of these, whether you do it by hand or by a calculator, you're going to end up with 1 over 9. For example, in the first one, 11 goes into 99 9 times. It goes into itself once. It goes into 99 9 times. And you're going to get for all of these sides that their proportions are 1 over 9. So basically, what does that tell us? It tells us that these are similar triangles. The sides are all in proportion. So basically, we know two things. We know that that these triangles are similar, and because they're similar, all of the corresponding angles are congruent. And how is that important for answering the question? Find the measure of angle F. Well, because angle F isn't labeled, none of the angles in the actual roof, that bigger triangle, are labeled. So, this is what we're going to have to do. Well, let me scoot this back up. Since a triangle is 180 degrees with all of the angles that are in there, if we can figure out the measure of angle C on the model triangle, that should be the same value as angle F in the actual roof. So A is 26 degrees, B is 24 degrees, and we're just going to do a little, create our own little math problem. The measure of angle A plus the measure of angle B plus the measure of angle C equals 180. But we don't know C, we know A and B. So 26 degrees plus 24 degrees plus C equals 180. Okay, 26 and 24 is 50. So 50 plus C equals 180. Now, from algebra, you know that all you need to do now is subtract 50 from both sides of this to isolate the value of C. So, the measure of angle C is going to end up being 180 minus 50, which is 130 degrees. So, now that we know that measure of angle C is 130 degrees, we know by default, let me move this up, we know that the measure of angle F is also going to be 130 degrees. So I'm going to erase our little question mark, and I'm going to go ahead and label that. And there you have it. So all we did here, we labeled, if you don't have the triangles drawn, you can draw two triangles, and it doesn't matter how they look because you're going to have to do the math in order to prove that they're similar. You line up all of the sides, you create ratios with all of the sides of the triangles, one side corresponding to the side, one side of the smaller corresponding to the side of the bigger triangle, and you move on to the other side and make a ratio of that side corresponding to the side on the bigger one. And then at the end, they all have to equal the same proportion. When you prove that they do, you have similar triangles. Since you have similar triangles, all of the angles are congruent. And all you need to do is find the measure. All you needed to do here to find F was find the measure of angle C, since that was the corresponding congruent angle. And that was it on this one. I hope you learned something today, and we will continue our discussion on triangles in the next video, doing some more proportions. So thank you for watching. Stay tuned and have a great day.